Hello students, welcome to this today's session. So I hope that you are all well and good. So we will be covering in today's session our theory, and in theory, so first of all, a small disclaimer, the images, text and other materials used in our presentation are for educational purposes only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the content immediately. Also, please note that the parts of the content may have been generated using generative AI, which is an experiment. Now, the outline for today's session is we are going to discuss mainly about Venn diagram, then operations on sets like union of sets, and then representation by Venn diagram of this union, then properties of this union, intersection of sets, then representation by Venn diagram of this intersection, then disjoint sets and its representation, and then we are going to see some properties related to the intersection, and then in last we are going to see the difference of sets, how we define it. So starting with what is Venn diagram. So simply these diagrams consist of rectangles and closed curves, usually circles. The universal set is represented by a rectangle and its subset, any subset, represented by a circle. Clear? It will be all clear if you see this example. So we are describing our universal set with 10 elements, 1, 2, 3 till 10, meaning first 10 natural numbers. Then its subset, here collection of all even numbers less than or equal to 10. Simple. Which is indeed a subset for this universal set. So this can be represented by Venn diagrams as universal set represented by a rectangle, and inside it we are having this circle denoting subset A, which enclosed some elements including 2, 4, 6, 8, 10. So this circle represents what? A subset of U, because it is enclosed inside this rectangle, meaning all the members inside this subset A belongs to the set U. And we are having some other elements, say 1, 5, 9, 3, 7. As you can all see, they are not in the set A. So these all are not enclosed within this circle. These are outside the circle. So inside the circle meaning elements of the subset, outside the circle meaning not a member. Clear? Now another example. So the same universal set with 10 elements, A, the same set A with elements 2, 4, 6, 8, 10, and set B with 2 elements 4 and 6. If you observe, B is your subset for A as well as for U. A is your subset for U only. Clear? Now this information can be represented by the using of Venn diagrams. How? Very simple. Rectangle shows set of this universal set. Inside this rectangle we are putting our elements from this set, representing that we are having this much of element in this universal set. Now this set, subset A of the universal set, is represented by a small circle enclosed inside this U, a universal set, as you are seeing here. So this is your subset A, and we know 2, 4, 6, 8, 10, all these 5 elements belongs to this subset A. So we are going to put all these 5 elements inside this circle in such a way that we also have another subset B for U. So B is your subset for both the sets U as well as A. Clear? Now, so we are going to represent this B subset using a circle in such a manner that that circle enclosed inside the bigger circle, which is for A, as you can see. And inside this circle B, we are having our 2 elements only. So we are going to put or enclose these 2 elements inside the circle. Now, from this only, this diagram only, what we can conclude is that we are having 1, 2, 3, all these elements in our universal set. In subset A, we are having elements 2, 8, 4, 6, 10, and in subset B, we are having only 2 and 4 elements. I hope concluding results from the Venn diagram is clear to you. If you are given with a Venn diagram, you must know how to conclude the results, how to conclude what is subset, what is the universal set given to you, and etc. Clear? Now, operations on sets. So first, we are going to discuss about unions, then intersections, and then difference of sets. So we will be covering these 3 operations. So first one is union. Can anybody say what is union in context of sets? Answer it, please. So a union is nothing. Yes, you can say that adding. So here in sets we do not add elements, but we join them. We take elements from other sets and combine those elements, not actually combining, adding like in real numbers, but collecting in a single set. So union of set A and B is another set which consists all the elements of A and all the elements of B. The common elements being taken only once. The symbol for union is this upward U, is denoted by the is used to denote the union. I hope this is clear. Now symbolically we write A union B and read it as a union B. So seeing this example, it will be all clear what is said in the previous slide. So if suppose set A is given to you with elements 2, 4, 6, 8 and set B also given to you with elements 6, 8, 10, 12. Can anybody answer what will be this A union B set? The Hindi lectures will be available on the website or mobile app also. So please do refer those videos. So very simple. So what we are trying to do is simply we are supposed to construct a set in which we are having all the elements from the set A as well as from set B. So solution. So creating A union B is very simple. Just write all the elements from set A as well as from set B and write the repeated elements only single time. So whatever the set you are forming will be your union set. Clear? So here in this case 2, 4, 6, 8, 10, 12 will be your union set. Note the common elements 6 and 8 have been taken only at once. Clear? So also an interesting point is your set A and B is your subset for the union set A union B. As you can see, all elements from set A belongs to this union, as well as for this set B, all elements from set B also belongs to this union. So A union B is behaving like a superset for both these sets. Now another example, A with 5 elements A, E, I, O, U, B with 3 elements A, I, U. Answer what will be its A union B, and also show the union of the given sets is equals to A, and why. Very simple. Solution. So in order to construct this A union B or write down the A union B set is very simple. Just collect all the elements from set A as well as from set B and write the repeated elements at once. Clear? So we will get elements A, E, I, O, U, which is same as the set A itself. So A union B is same as set A. Why? If you observed here, what happened is very simple, that B is your subset of set A. Yes, B is your subset of set A. If you are having such case, then your A union B will be the superset. In this case, A is your superset. Clear? And this can be verified by using Venn diagram. So please do try that. Clear? So if you are facing any difficulty in understanding the Venn diagram for this example, so please let me know. Now this example illustrates the union of sets A and its subset B is the set A itself, which is your superset. So if you are having any such case that a B is a subset of A and you have to find out A union B, you immediately answer, the answer is going to be A. Now this example, let X collection of 3 elements, and elements are Ram, Geeta, Akbar, be the set of the students of class 11th who are in hockey team. Clear? Now another set Y, collection of 3 elements, saying 3 students, Geeta, David, Ashok, and these 3 students are in the football team. Obviously they are also from the class 11th. Now you have to find out the union set X union Y and interpret the set, what it actually means, what set gives to us. You have to interpret it. So solution, X union Y will be your set with collection of all the elements from the set X as well as from the set Y, and we only write once the repeating elements. So Ram, Geeta, Akbar, David, Ashok will be our X union Y set. And this set, the interpretation is simply students from class 11th who are in hockey team or who are in football team, or might be they some of them might be in both hockey as well as in football team. In this case, Geeta plays both hockey as well as football. Clear? So we used or because of this union definition. if you paid attention to the description or definition for this union, we said X union Y will be our set such that, so if you try to write down its set builder form, it will be like X collection of X such that X belongs to X or X belongs to Y. It might be possible that X belongs to both, which is already covered here. So we want our X, such X's, either they are not either, they are belongs to X. If they are belonging to X, you can collect them. If they are belonging to Y set, you can collect them. If they are belongs to both sets, you can collect them. Clear? And we will use AND for different purpose. Clear? Now, union by Venn diagram. So simple, union of two sets A and B is the set C. So A union B generates another set which is C, which consists all those elements which either in A or belongs in B, or including those which are in both. Clear? So in symbols we write, so as we just said, A union B is simply collection of all X such that X belongs to A or X belongs to B. You are collecting your X. If X belongs to A, you can collect. If X belongs to B, you can collect. If X belongs to both, still you can collect. The representation will be like this. So U represents your universal set, which is represented by this rectangle. So rectangle shows your universal set. A is your subset for this set, universal set U. So inside this rectangle we are drawing this circle. Another subset which is which might be different or not different to this subset A. So we are trying to overlap some part. This might be the case that we can have some common elements. Clear? Now A union B gives what? By definition, A union B is nothing. You are doing what? You are creating a set in which you are collecting all elements from A as well as from B. Meaning you are shading this complete circle as well as this complete circle for B. So you are getting your whole area to be shaded. And this whole blue area, blue region you are seeing is all what? A union B. This represents A union B. Clear? So Venn diagram showing union of two sets. Clear? Now, some properties related to union. A union B is same as finding out B union A. As you are collecting, first say at first you are collecting all elements from A and then you are collecting all elements from B, which is same as saying collecting all elements first from set B and then from A. Eventually you will get the same collection irrespective of the orders of the elements. Clear? So this property shows commutative law. Now second says about associative law. If you are having three sets, simply if you are performing union to first two sets A and B, so A union B and then union C, this set, this end result will be same as if you find out the union for B and C and then union with A. Clear? Now, law of identity. In this case, A union empty set is simply your set A. Now, idempotent law. A union A itself is simply A. Universal set union A will be your superset, which is U. So, law of U. These all 5 properties can be verified using what? Can somebody answer? Using Venn diagram. Clear? So, if you are facing any difficulty, please let me know. Or you can join the Zoom meeting. Clear? After or before this session. Now, intersection. So, in this definition, we are going to use AND word. So, intersection of sets A and B is the set of all elements. So, we are collecting what elements? All such elements which are common to both sets A and B. So, we are generating another set from this intersection. Symbol is downward U, as you can see, which denotes the intersection. So, in this intersection set, we are collecting common elements to both sets A and B. Clear? The intersection of two sets A and B is the set of all those elements which belongs to both A and B. So, here we used AND word. So, AND represents what? AND says that your element must be in A as well as in B. We cannot have an element in this set which only belongs to set A or B. Symbolically, in mathematics terms, A intersection B is simply collection of all x such that x belongs to A and x belongs to B. So, let's have an example to understand the definition more. So, starting with, or assume our set A with elements 2, 4, 6, 8. Another set consider with elements 6, 8, 10, 12. Find A intersection B. So, can somebody answer? The intersection? Correct, 6 and 8. Why? Because definition says so. So, definition says you have to collect what type of element? Common elements to both sets, and common elements are only 6 and 8. So, A intersection B will be your set 6, 8 in roster form. Another example. So, also please do answer this. If you are having set X with elements Ram, Geeta, Akbar and Y with element Geeta, David, Ashok, then find the intersection AX intersection Y. So, you have to collect common elements from both these sets. So, you are having how many common elements? Only one, Geeta. So, solution, Geeta is the only element common to both. So, X intersection Y will be your singleton set with element Geeta. Clear? Now, this example, suppose this set A with elements 10 elements, collection of first 10 natural numbers, set B with 4 elements 2, 3, 5, 7, find out the intersection and show that A intersection B is B. And can somebody answer why we are getting A intersection as B? Is there any general remark about this point? Yes. Very good. So, B in intersection cases, if you are having a set which is a subset of another set, then your intersection will be the subset set. In this case, B is your subset for this set A. Your A intersection B will be the subset set which is B. Why? It all depends on the definition, because we are collecting all the common elements in A intersection B sets. If we know about B is an intersection for set A, then obviously the only common elements to A and B is the set B itself. Clear? So in general, if you are having B subset of A, then you always going to have A intersection B equals to B. I hope all these three examples are clear to you. Now, intersection by Venn diagram, simple. So, intersection of two sets A and B is the set of all those elements which belongs to both A and B sets. Symbolically, A intersection B is simply collection of all x belongs to A as well as in set B. The shaded portion indicates the intersection of A and B, and the shaded portion in this Venn diagram. So this shaded part, this region is your A intersection B, which represents what? If you try to observe here, this region is common to both circles A and B. So this common part shows me A intersection B region. Clear? If you have to find A union B, then you have to cover all the region or all the parts covered by these two circles. If you are talking about union. Clear? In intersection, only common part is used. I hope it is clear. Now, disjoint sets. Very simple. If the intersection between two sets, in this case A and B, if you are getting the intersection as empty or phi, then you immediately say your provided sets are disjoint sets. Clear? Meaning, so as this word suggests, disjoint meaning we do not have any common element to both given sets. Clear? So by Venn diagram you can directly represent disjoint sets by creating or drawing two distinct circles which are not intersecting anywhere. So two distinct circles A and B. Clear? So if you have to find out the union for these, it will be very simple. So just cover all this circle A as well as this circle B. So your union will be these two shaded part or collection of all elements from set A as well as from set B. Now, some related properties to intersection. So first one is commutative. Commutative is very simple. A intersection B is same as B intersection A. Here you are collecting all common elements from set A and then set B, and the same goes for this. If you collect common elements from set B and then set A, you will get the same set. Now, associativity holds here. So if you are having three sets, suppose A, B, C, and if you are doing intersection in between first two sets A and B, so A intersection B and then intersection with C, so A intersection B, then A intersection B intersection C, the result will be same as doing B intersection C then A intersection with B intersection C. Clear? So associativity shows if you have 3 sets, so doing intersection with first 2 or last 2 sets, the final answer won't be affected by these order of the intersections. Now law of phi and u. So empty set intersection A will be empty set. Why? Because you do not have any common elements to both sets. So eventually you will get your empty set. Now what about U intersection A? So U intersection A is simply A because A is your subset for this set U. So if you are going to collect common elements to both sets, eventually you will be getting your set A. Clear? Now fourth, A intersection A is simply A. Very simple. And A intersection B union C. This is your distributive law, as you can see. Here you are using intersection here and union here. This is equal to A intersection B union A intersection C. Clear? So we are not going to prove. Clear? If you are, you can, the proof is for you, or you can verify all these 5 properties for intersection by using Venn diagram. Clear? So fifth is nothing but your distributive law. It distributes your intersection over union, as you can see. So if you are having 3 sets and we are having operation like this, A intersection and then B union C. So first we have to do what? Union and then intersection with A. So one thing you can do is simply find out the union first and then intersect with A. This, whatever the set you are getting is same as finding first intersection of A and B and A and C intersection and then union them. The final answer would be the same. Clear? Now, difference of sets. In real numbers, you know what difference gives you. In sets, how we are defining our difference? Very simple. We are doing nothing but simply we are collecting all elements. Suppose if we have to find out the difference A and B, meaning we have to collect elements which belongs to A but not belongs to B. In symbols, A minus B represents elements belongs to A but not in B. So in set builder form, you have to write collection of all X such that X belongs to A but X does not belongs to B. So another perspective is simply collect all elements from the set A and then eliminate all elements from this collected set. What elements I am talking about? I am talking about which belongs to B. So first collect all the elements from the set A and then eliminate all the elements which are common to set B. It will be all clear if you see an example. So don't worry if you are not getting the definition. So clear? So the Venn diagram representation is like this. U, your universal set represented by this rectangle. 2 sets like this represented by these 2 circles, overlapping circles. So what is happening here? We are collecting all the elements of A. Okay, so suppose we are collecting all the elements of A. So these elements are also A. Yes, now what we are trying to do is we are collecting only those elements which belongs to A and not belongs to B. So what we are doing is simply collecting all elements from A and then removing all the elements which are common to A and B. So remove all these common elements. Eventually you will get the blue shaded part. Clear? I hope this representation by Venn diagram of this difference set is clear. Now let's understand by this example. A with 6 elements 1, 2, 3, 4, 5, 6. B with 4 elements 2, 4, 6, 8. Now find out A minus B, this difference, and B minus A. So answer. Very simple. So in order to find A minus B set is very simple. If you are facing any difficulty, let me know. So how you are going to find A minus B? Very simple. Just first of all write the set A itself. Clear? So writing set A, very direct and simple approach to write any difference of two sets. So writing all the elements or the set itself A here. So we wrote. Now what we are trying to do is subtracting, meaning eliminating. In this case, subtracting meaning eliminating. We are eliminating. Now we are eliminating B elements from this set. So eliminate 2 if it is present here. Yes, 2 is there, so eliminate it. 4, eliminate 4. 6, eliminate 6. 8, 8 not present in this set, so we do not worry about this element 8. So whatever the set we are left with will be our difference set A minus B. I hope this way of representing A minus B or writing down A minus B is clear to you. The same goes for this difference. So write down the complete set B 2, 4, 6, 8 and eliminate all the elements which are common to set A. So 2 belongs to A, eliminate it. 4 also belongs to A, eliminate 4. 6 also belongs to A, eliminate 6. You only left with this singleton set. And this singleton set will be your B minus A set. Clear? And here we observed in general we can say that A minus B is not equal to B minus A. Clear? And the same also happened in real numbers. If you see that 2 minus 3 is not same as 3 minus 2. The right hand side is positive number, left hand side is some negative integer. Clear? I hope this example is clear to you. Now, another example. So, try to answer this. V with 5 elements A, E, I, O, U. B, another set with 4 elements A, I, K, U. Find out V minus B and B minus V. Clear? So, please comment. Now, solution. Very simple to write V minus B difference. How? Starting with writing down this B set A, E, I, O, U. Yes, and then what we are trying to do is very simple, to eliminate all the elements which also belongs to the set B. So here A belongs to B, eliminate it. I belongs to B, eliminate I. K and U. U belongs to B, eliminate u. So we only left with these two elements, and the set in which we are having these two elements will be our this difference set v minus b. Clear? The same goes for b minus v. I hope the approach is clear. So the same conclusion, v minus b is not equals to b minus v. Clear? So in general, if someone says, do we have a minus b same as b minus a? You can answer them, no. In general, we do not have this case. Now, there's a remark. A minus b is your difference set, a minus b. This is your intersection set, a intersection b. This is your another difference set, b minus a. If someone says, find out the collection of all the elements which are common to these three sets, can you find out? No. Why? There will be no common elements to all these three sets. The intersection will be empty, meaning they are all mutually disjoint sets. The intersection of any of these two sets is simply null set. Clear? So, try to understand from this Venn diagram. This part, this light blue shaded part represents your A difference B set. This set, A minus B. This middle part, the common part, is represented by A intersection B. And this leftover part is also the difference of B and A, B minus A. And you can easily see, observe that we are having no such common elements to all these three regions. Clear? So, they all are mutually disjoint sets. So, mutually meaning simply, if you pick any two pairs, the intersection, so mutually means in between two. Here, in between two. So, pick any two. So, we are using term mutually. Clear? Meaning any two. Picking any two sets, A minus B or A intersection B or B minus A. Any two. Now some related questions. So based on previous classes as well as this session. So please do answer this. Write down this first point given in set builder form. So set A described as collection of all x such that x is your positive integer less than 10 and 2 raised power x minus 1 is your odd number. So you have to collect such x's satisfying these two conditions. Now for second, C is your collection of all x such that x square plus 7x minus 8 is equals to 0, where x belongs to set of reals. So solution, I hope you all tried. So first of all, observe this, that a 2 raised power x minus 1 will always be an odd number for any x belongs to positive integer. So in particular, 2 raised power x minus 1 is an odd number for x 1 to 9. So in our collection, we are going to have first 9 natural numbers. We are not going to include the 10 here. Why? Because we want positive integers less than 10. Clear? Now for second, so first of all, we need to solve this quadratic equation. So the factor form for this quadratic equation is simply x plus 8 times x minus 1. And from this form, we can easily conclude that the two values for which the quadratic equation going to be satisfied are minus 8 and 1. And both belongs to set of reals. So the set C in roster form will be minus 8 comma 1. Clear? Now state which of the following statements are true and false. So first statement is saying 37 does not belongs to the set in which the collection of x such that x has exactly two positive factors. Second, 28 belongs to the set is collection of all y such that the sum of all positive factors of y is twice of y. Third, 7747, this number belongs to the set and set defined as collection of all t such that t is a multiple of 37. Now, so for first, the statement is false. Why? Because 37 has exactly two positive factors, 1 and 37 itself, meaning it satisfies the condition described above. So 37 indeed belongs to the set defined here, but in a statement we are given with that it does not belongs to. So this is false. Now second one is true. Why? Because if you find out the sum of positive factors for this number 28, so factors are, first of all, factors are 1, 2, 4, 7, 14, 28. Now the sum is simply 56, which is equals to twice of 28, satisfying the condition described in the roster form, set builder form, meaning this 28 number belongs to the given set. So true. Clear? Second one is true. Now third one is false because 7747 is not a multiple of 37. You can easily verify that by long division method. Next question. So n set of first 100 natural numbers. First part is write the subset A of n whose elements are odd numbers. So write down the A in roster form. Second, write down the subset B whose elements represented by x plus 2, where x belongs to the set capital N, and capital N is your this set, not natural number, this set. Now solution. For first part, very simple. You have to collect all the odd numbers starting from 1 ending 100. Simple. So if you start collecting, you will get 1, 3, 5, 7 till 99. Clear? Now for B, you have to collect numbers of the form x plus 2, where x belongs to the set capital N. Clear? So just use x from here 1, 2, 3 till 100. So if you use x as 1, y will be 3. If you use x as 2, y will be 4, and so on. Then your set B will be 3, 4, 6, 4, 5, 6 till 100. Why we are getting these elements only? What about 99 plus 2 and 100 plus 2? What about these elements? Why? Why we are not taking these elements in this set B? Because we want our B to be a subset of N. It is clearly mentioned here. We want our B set to be a subset for this set N. If you include these two elements, B won't be a subset. Clear? So the only reason to eliminate these two elements is this word subset. I hope this is clear. Now, this question, E set with 5 element 2, 4, 6, 8. If N represents any member E, then write the following sets containing all members represented by N plus 1. Second, N square. So let me first of all clear this question. So what we are trying to do is simply construct a set in which we are going to have elements of the form N plus 1 and for second N square, where N represents your member from this set E. E described here in roster form. Clear? So you have to construct these two sets accordingly. So solution. So very simple. E already given to us with these 5 elements 2, 4, 6, 8, 10. For first, the set is going to be, so A is simply collection of all x. X must be of the form N plus 1 and N belongs to the capital E. Now 2 belongs to E. So substitute 2 in place of N. We will get x as 3. For 4, x will be 5. And so on. We will get 5 elements. 3, 5, 7, 9, 11. Clear? Now for B, collection of all x such that x is of the form N square and N belongs to the set E. So 2 belongs to E, meaning x must be 2 square, which is 4. 4 belongs to E, meaning x 4 square, which is 16. 6 belongs to E, meaning x will be 36. And for 8 it will be 64. For 10 it will be 100. So we will have 5 elements corresponding to each element of E. Clear? So 4, 16, 36, 64, 100. I hope these two parts are clear to you. So this is it from this session. Thank you for joining this session, and please do register yourself on the Sathee website. Enroll yourself into this course. Clear? So if you are facing any difficulty related to any subject or regarding enrollment or registration, please do contact us, or you can join Zoom a live doubt clearing session also. So here we have to end this meeting, this session. So thank you once again joining with us.